Hi everyone, in this video we're going to go through questions 1 and 2 of the 2025 General Maths Financial SAC. Anyway, it's all in the front there. Got the details. Let's go. Don't want to make it too long, but I am committing to 2 questions per video so that it's a little bit more manageable. Please pause at any time and make sure you're making annotations to your SAC. If you got anything wrong, make sure you fix it up. Or if I say something that you think will be useful in the future, so for exams or something like that, make sure you annotate that or jot that down as well. All right, question 1. So Frankie is saving to buy a home. He has $45,000 saved and wants to invest in a compound interest account. All right, so that's important. I'm going to highlight it. I know the answers are there. It just makes it a quicker video if I have the answers already there. Bank of Mentone offers Frankie interest rate of 4.4%. compounding quarterly. All right, so make sure you take note of those important things. The rule to calculate the value of the account after n quarters is, okay, so we've got a rule there. We don't have the value of R, and often in an exam it'll start off easy like this where you've, it's a show that question. So we've got R is equal to this. So instead of being given it in the rule, it's been given to you in the question. You have to show how it's calculated. Now you do have to show a calculation to get that number. So I always say to students, just pretend that answer's not there. All right, just pretend you can't see it and that it's asking for R. Because if at any stage you're substituting in the answer, then it's not a show that question. All right, so you're being given the answer of 1.011, and that is so you can use it later on. Okay, so just take note of show that questions. Just pretend the answer's not there and you do the working out to get that answer, and hopefully you get the same answer. Now I have seen on past exams students not get the same answer and then thought that the exam was wrong. All right, they often checked enough that you can be confident that it is actually correct. So if you don't get 1.011, your calculations are incorrect. All right, let's move on. Frankie needs to save $110,000 for his home deposit. How many years will it take his initial investment of $45,000 to first be over $110,000? All right, so there's several ways you can do this question. I just did it by solving this equation. So we want basically Vn to, Vn is equal to 110,000, and we're just solving for n. So we're keeping the rule, we're just solving for n. Now it's not a show that question, so you don't have to show any calculations. In the SAC, a lot of students wrote 82 years. It is actually 82 quarters. So if you were to put solve into your calculator, you would get 82. That is quarters. So n is number of quarters. So you did have to convert it into years. So 21 years. So if you didn't do that conversion, you were penalized. So make sure you take note of what the question is asking. All right, Bank of Mentone has a compound interest account that has an interest rate of this. All right, compounding monthly. Explain whether this is better option for Frankie compared to the initial account that had a rate of 4.4% compounding quarterly. All right, so the easiest way to do this is just to calculate the effective interest rate for both of them. There were quite a few students who did calculate the interest. The problem when they did that is, one is quarterly, one is monthly, and didn't really take that into consideration. As you can see, it is so easy just to calculate the effective interest. So on your calculator, you can just go to interactive, financial, and where are we? Interest conversion. And you just put it into your calculator. It even prompts you what to put in. So you can put in 12, and you can put in the 4.34. I did see quite a few students use the actual formula. So you don't need to use that formula unless it's maybe a show that question. You can just plug it straight into your calculator. So if you do use the formula, the problem with that is you're prone to making errors. It's quite I don't want to say complex, but there's a lot to it. It's not that straightforward. Also, when you're doing your effective interest rate, just don't do it to maybe 2 decimal places. I would definitely do it to 3 or 4. And some people got the effective interest rate incorrect. I don't know whether they left didn't change the 12 and the 4, I don't know. So no, this option isn't better. So this is actually a loan. So if we've got a loan, we want the lowest interest rate. So we want the lowest effective interest rate. If it was an investment, we would want the highest effective interest rate. So there are a couple of students who got that mixed up. And that kind of told me that they may have just read some theory as opposed to actually understanding what they're answering. So make sure you have a good understanding of the difference between an investment and a loan. And, if you've got a loan, obviously you want a lower interest rate. If you've got an investment, you want a higher investment rate. All right, after doing the calculations, Frankie decides he will need to make additional payments into the investment so he can save the money sooner. He has an annual income of $175,000. Based on his income, Frankie has determined he will choose one of the following investment options. So he can invest $2,625 each quarter or $4,375 each quarter. And you are to choose one of those options. So you can see I've just split option A and B. Option A on the left, option B on the right. This question was not done very well because a lot of people forgot to multiply by 4. So it was percentage of the annual income. So you did have to actually multiply it by 4. And then for E, it was done quite well, although some students forgot to add on the payment. So remember, he was up here adding on these additional payments. But if you did that incorrectly there, but then correctly in part 2, you were given consequential marks, and that would have been written on your paper that they were consequential. And most people who forgot to add the extra payment went on and did the recurrence relations correctly. Some people got the recurrence relation incorrect, may have put the 175,000, which is his salary, or wage, whatever it was called, annual income. So we're obviously penalised in E, but not penalised again in part 2 if it was used correctly. Okay, so just making sure that it's used correctly. There were also a lot of rounding errors here. You weren't really penalised if you had already been, you weren't penalised more than once for rounding, but just make sure when you're doing recurrence relations that it's always to 2 decimal places. So here we've got 0.32, 0.57. I mean, technically I should have here 0.00 and 0.00. But you can't, we're not a fancy cafe, so don't leave it as 0.2. All right, never as 1 decimal place. All right, moving along, by making these additional payments, Frankie will be able to save $110,000 deposit sooner. Beautiful. Given Frankie has chosen the compound interest account that has an interest rate of 4.4, compounding quarterly, determine how much sooner he'll be able to save the $110,000 deposit. All right, so I think the biggest problem students were making here was when they're putting things into their financial solver and not having the negatives in the right place. So this is obviously an investment. He's not buying, he's saving for a home, but hasn't purchased the home. So when money goes into the bank, it has to go in as negative. So just making sure that was negative, and the payments are also negative because that money is going into the bank. Some students got their quarters and their years mixed up. Yeah, that was the main issue there. Some rounding, which I didn't, if I would have preferred 15.75 as opposed to 16 years, but I didn't really penalize that. The same here. So just making sure that for this one here, I would leave it as 15.75, only because we do have quarters. So it's 15 years and 3/4, and this is 17 years and 1/4. But also wasn't overly pedantic about that. All right, moving on to question 2. So Frankie chose to make additional payments of 5,200 per quarter. Information regarding the account in the first 3 quarters is shown in the amortization table below. All right, so he's decided to make more. So he's making 5,200. This was done, actually part A is first. Sorry guys. It's another show that question was done quite well. Again, you've got to pretend that this answer hasn't been given to you. So I wouldn't go blacking it out on your paper, but you've got to get into the habit of pretending it's not there. So that means you had to use values from the table that actually show how the 4.25% is calculated. Students who got this wrong often use the 4.25 in their working out. I've got some young kids outside my window playing, so if you can hear them riding up and down, that's pretty cool. So for the table, if you got this one wrong, then but you calculated the other 2 correctly, but with the incorrect amount, you would see consequential on there. So some students just rounding the first value incorrectly. Some getting partial marks because they got maybe one thing correct. I don't know. It's hard to say. The biggest thing was the rounding. All right, part C, determine how many quarters it will take Frankie to save at least 110,000. So N is what we're solving for. So the interest rate is 4.25. Again, I'm wondering if the negatives weren't there because this question is not a hard question, but I did see a lot of answers in the 80s. So only 11 quarters. And when you think about the question, so after 4 quarters, we get this amount here. So, I mean, it's not going to take us much. Well, I know we're fairly under that, but definitely not another 80 quarters to get to 110. So trying to think about your question. All right, I'll do question 3 and 4 in a separate video. Bye guys.